Hello, welcome. Let's try to solve another Leetcode problem. 1542. Find the longest awesome substring. So we are giving a string S, and the substring can be reordered. So for example, we have a substring of 2, 4, 2, 4, and 1. So this is a palindrome substring. So this is awesome substring. Yeah, because all those numbers can be reordered. So for example, for here, so it can be reordered like this: 2, 2, 4, 4, and we're gonna put 1 in the middle. So it's gonna be a palindrome, awesome substring. Yeah, and this is the longest substring, so we're gonna return 5, and we cannot find a longer one. Yeah, but how can we solve the problem? Normally, we may think about O(n) square like we are using the brute force, but O(n) square is not possible. So for example, we have numbers like maybe A, B, and yeah, let me just use numbers. Maybe numbers would be suitable for the problem, because our problem is just numbers from 0 to 9. Yeah, so let's just use numbers to prepare an example. Yeah, so for example, we have numbers like 2, 4, 4, 2. Yeah, let's just try this example. So this is a palindrome. Yeah, and for us, we want to check the palindrome. Maybe we're gonna use the prefix. Yeah, if we are using prefixes to check the palindrome, basically we're gonna check each bit. Yeah, so basically we're gonna use the XOR operation to check it. So for example, from this 2 to this 2, we're gonna check if this string is a palindrome. So how can we check it? We're gonna use a prefix XOR to check. So for example, this 2 XOR with this 4, and this 2. But from the beginning, we're gonna set a 0. Yeah. So this means 0 XOR with 2. What is that? It is a 2. 2 with XOR 4. I will not write it yet, but I will calculate it later. Yeah. So 4 with XOR 4, so it is a 0. And 2 with XOR 2, it is a 0. Yeah. So it means why we are doing the XOR operation. So if it is 0, basically means it is a palindrome, and the length of the palindrome must be even. Yeah, because it is 0. Yeah. Yeah, but yeah, this is just for the case that the numbers cannot be 0. Let's just check the numbers. So yeah, the length is from 1 to 10 to the power 5, and S consists of digits. So it means this numbers can also be 0. Yeah, but we're gonna turn each of the numbers to bit. We just check the bit operation. So for example, we just use the 4 bit. So for number 2, so this is number 2, and the bit gonna be 0, 0, 1, 0. So we're gonna check the bit from the right to the left side. Yeah. And for number 4, it's gonna be 1, 0, 0, and here gonna be 0, because this is the high bit, this is the low bit. And for another 4, it's gonna be 0, 1, 0, 0. And for another 2, last 2, it's gonna be 0, 0, 1, 0. Yeah. So if we want to check if these strings, but for the first one, we're gonna set always to be 0. Yeah. Now we can use the prefix XOR or prefix sum to check from I to J if it is a palindrome or not. Yeah. But how can we calculate it? So we can directly calculate it like this. So this is this number, and then we're gonna check the prefix sum. The first one gonna be the same because it is 0, 0, 0, and 0. Now we're gonna check the prefix sum. So this one with this one is gonna be XOR 0, 0, and 1, 0. Yeah. So what about the second one? This one XOR with this one, it's gonna be 0, 1, 1, 0. Yeah. Now we still need to use XOR, because we can find some pattern according to this kind of XOR operation. Now we're gonna still use XOR operation. So this one with this one, because this one with this one, because it is the prefix XOR. So 0 0 is gonna be 0, 1 1 is gonna be 0. So 1 0 gonna be 1, 0 0 gonna be 0. Let's start to finish the last calculation. So 0 0 is gonna be 0 and 0. This one and 1 is gonna be 0, and last 0 and 0 it is 0. So did we find some pattern? As we can see, the last number it is 0 0 0 0. What about the first number? It is 0 0 and 0 and 0. So did we find some pattern if it is just a 4-bit number? So we found that the first state, we're gonna call it state 0 0 0 0. We're gonna call it state, but here we're gonna define it as a mask. So the mask is the start from 0. So this is 0. So while we are doing the XOR operation, so this is a prefix XOR, XOR with this one, XOR, XOR, and XOR. So we can find some pattern. Maybe we can get 0 0 0 0. It's exactly the same as the previous one. So this is calculated like before. If we find some patterns like this, it means we find a palindrome, and the length of the palindrome must be even. Because it's exactly the same. Only even numbers like 2 2. 2 XOR with 2 can become 0, because this, as you can see, this is 0 and this is 0. Or maybe it's the same. I mean, if the state is the same, so this state is 0 0 0, and this state also 0 0 0. It's the same. So we are sure it must be the length of the palindrome. The awesome substring must be even numbers. So as you can see, this is so we're gonna call it. This is the index 0. Because this is a prefix index 0, 1, 2, 3, 4. So what is the length? Because it is the prefix XOR, so the length is 4. 4 minus 0, this is I, or this is maybe we're gonna define it as this is I, and this is J. So I minus J, 4 minus 0, it is 4. So this 4 gonna be the final result. But what if we find some 0 in between these areas? If we find some 0 0 in these areas, but we cannot update it. Because for this 0 and 0, we want to keep it as small as possible. I mean, we're gonna keep the index as small as possible. Maybe from some other places, for example, index 2, we find 4 zeros, but we cannot update the hash table or the index array. So for this problem, I'm gonna use the index array, because it is much more faster than hash table while we are using the array. So we're gonna prepare an index array. So the index array, I'm gonna prepare index array. So inside the index array, I'm gonna prepare a padding. So the first one is the padding I'm gonna prepare -1. Because for the index array, the state is the index, and the value is the index of the numbers for those numbers. So this -1 is the first index. Because the first state, basically we don't have this state, but we're gonna prepare an initial state as 0. Just easy for calculation. Otherwise, if we find 4 zeros, where is my first state? I cannot find it. I cannot get the result of 4. So I have to prepare something. So I'm gonna prepare a -1. So this means if this is the -1, so I'm gonna start from here, gonna be 0, 1, 2, and 3. Because I prepared a -1. So if I find index 3, it is 4 zeros, so 3 minus a -1. So I got a 4. 4 is my final result. So this is just for the even palindrome. If it is an even awesome substring. For the even, it is okay if we find something it's the same. Maybe another state. Let me clean a little bit about these areas maybe. So this is just for the even length of the palindrome. But what if it is odd? What are we gonna do? Yeah. For our example, yeah. So for our example, maybe from here, we have numbers like 2, 4, and this is 2 and 4. Yeah, we have this kind of numbers. As we can see, what if we don't have this number 4? So maybe 2, 4, and 2, this can also be a palindrome. Yeah, because 2, 4, 2, of course it is a palindrome, but the length of the palindrome is odd. It is not even. Yeah. So what happens for the odd? Yeah, so as you can see here, so this is like 0, 0, 0, 0. This is the initial value, initial state for the mask. It is 0. And here, currently, while we are having this number 2, yeah, so this is for, we have a string like 2, 4, and 2. It's going to be like this. Yeah. So while we are checking this number 2, we have 0, 0, 1, and 0. Yeah. So this means at some bit, so for the bit, this bit 1, and we can compare with the first state 0, 0, 0, 0. There's only one bit difference. It is at beta. So this is a beta 1, 2, 3, 4. So it is only at this bit. Yeah, at bit 1. Or we can call it 0, 1, 2, 3. I think we can call it 0, 1, 2, 3. It is only at this bit. Yeah. So this means for this bit, there's only one number different, and for all other numbers, all those numbers is the same. Only for one bit, it is different. So this means this can become an odd number, and it is a palindrome. Yeah, but how can I explain about this case? Yeah, as we can see, the number it is 2, 4, 2, and here it is 0, 0, 0. This is 0, 0, 1, and 0. Yeah, so it means we can only flip one bit at this place. For this 0, we can flip 1 to 0 and make it exactly the same like this state. Yeah, I think yeah, basically for example, if it is even, we have 4 zeros and another 4 zeros. Yeah, so this means we must find some even substring like 2, 2, 4, 4 or something like that. Yeah, but what if it is even? It is odd, like 2, 4, and 2, and we have some numbers. So this is 0, but for here it is 0, 0, 1, and 0. There's only one bit different. Yeah, we can only find one bit yeah, we can only find one bit different, and this bit actually is for the yeah, I think it's for the 1, 2, 3, 4. For 2, it is 1, 0, 1, 0. We have 2, 2, and for 4, it means we have yeah, basically I forget about my examples. I forget it is 2, 4, 2 or 2, 4, 4, but it is okay. Yeah, so for example, it is 2, 4, 2. Yeah, so from this 2, yeah, I think it's 2, 4, 2. It is 0, 0, 1, 0, and 4 it is 0, 1, 0, 0. And for this 2, yeah, I did a mistake at these areas. Yeah, I did a mistake. That is why it's so confused. So for, yeah, if this is a 2, yeah, if this is a 2, yeah, let me clean it here a little bit. So if this is a 2, it's gonna be 0, 0, 1, 0. Yeah. So we can use XOR XOR operations to calculate to calculate these three numbers from here. So we can calculate from here to here to here. Yeah, so we can use XOR. Why we are using XOR? For those three numbers, like 1 1, it's gonna be 0, and here gonna be 1. So the final result gonna be 0 1 0 and 0. Yeah. So if we have a number like this, so this number 0 1 0 0 is the XOR operation of 2 4 and 2. Yeah. So this means from the first one it is 0 1 and 2. Yeah. This means at bit 2, definitely we want to change this to 0 to make it the same. Yeah. As you can see, it is number 4. There's only one number 4. It is in the middle of the palindrome. Yeah. So this seems it works. Yeah. Yeah. Basically, it means if we have a string, for example, like 1 0 1 1, and we have another string, maybe 1 1 1 1. There's only one bit different, and we can flip our bit from here. If we can flip this bit, we can make it exactly the same. If it is exactly the same, it means it's like the even palindrome. Basically, we can make it. And we can at most flip one bit. We cannot flip two. Because one bit only means there's only one. This just means if it is a odd palindrome, there's only one unique number. Yeah, for all other numbers it is even, but there's only one unique number. Yeah. So if we understand from here, normally we can solve the problem. Yeah. So we're gonna solve the problem like this. We're gonna prepare a mask. So the mask is gonna be 0, and 0 is the initial state, and we're gonna prepare an index array. So the index array, as I explained earlier, from the first index it's gonna be -1, and all other index I gonna set infinity. And this index array is just a hash table, and the index is the mask. So for example, my mask 0. So this means at mask 0, I have an index as -1. Normally I don't have this mask. But now I'm going to check the string one by one. I mean all those numbers one by one, and I'm gonna update the mask. Yeah. So if I find a result, normally it is inside the index array. I can find it. So for example, my result, yeah, gonna be the maximum of the result with my. So I'm gonna enumerate the string. It's gonna be I minus the hash table, the index hash table inside. Yeah, it's gonna be the mask. So the mask is my updated mask. Yeah. Basically it's gonna be like this. Yeah, it's gonna be the maximum of my result with I minus the index with mask. So this is basically a two-sum operation. Yeah. Now let's just get back to the coding. As I explained, I'm gonna prepare index array. So the index array is just a hash table. The k is the index, so it's gonna be the state. It is the mask, and the value is just the index. From the beginning, I'm gonna prepare a -1, and I will set all other mask, all other index or all other mask to be infinity. Yeah, this infinity you will see it later on. I will explain why I set it as positive infinity, and this would be times yeah, how many states? Because there are only 10 different numbers. I mean 0 to 9. It is only 10 different numbers. So our state would be 1 left shift with 10 and -1, because for this -1 we prepared a padding with -1. Yeah, so this is gonna be a -1. So in total this is gonna be all the total state. Yeah, so the state is gonna be the mask, the index, so from 0 to 1023. Yeah, so let me make a parenthesis. Yeah, now we are sure we prepared the state array, the index array, I need to prepare my result and mask. So the result I'm gonna set a 0 and mask gonna be starting from 0. Now I'm going to enumerate all the numbers inside the string S. First of all, I'm gonna update the mask. So as I explained, it is a prefix sum. Basically, it is a prefix XOR of the mask. So it's gonna be the mask with my current number. So what is my current number? So my current number is odd with this character C and minus odd 0. Yeah. But we're gonna check the bit. It's gonna be 1 left shift to this bit. So for example, if this number may be 3, it is 3. So 3 minus 0, it is 3. So 1 left 3 bits to the 1 shift 3 bits to the left, and then we're gonna XOR with the mask. Yeah. So in this way, yeah. So in this way, basically, we can update the mask. Yeah. So if it is number 2 or number 4, we can update like 4 bits to the left. Yeah, let me explain these areas maybe. Yeah, so for example, our initial state is 0, 0, 0. And if we have a number 3, it's gonna be like this. It's gonna be like, it's gonna be, yeah, because it is an XOR operation, so it's gonna be like 1, 0, 0, 0. So for example, if the next number is 2, yeah, so this is for number 3. So if the next number is 2, so it's gonna become 1, 1, and 0, 0. So this is for number 2. Yeah. So for example, for the next number, maybe I will not try 4 because it is too long. Maybe I'm gonna try 3. So if I try 3, 1 XOR with this one, it's gonna be 0, right? So here gonna be 0, 1, 0, 0. So I'm gonna simulate with 3, yeah. And the next one I'm gonna simulate with 2. So if it is 2, it's gonna be 0, 0, 0. So I can simulate the 2. So basically the string is 3, 2, 3, 2. Yeah. So this operation is for the different state. Yeah. So we have to design something like this to keep the different state. And for each of the numbers, we're gonna update the state. So for example, if it is 3, we are at this state. And now we have number 2. We use the prefix XOR to accumulate the state. It's gonna be this one. So for the next one, for the number 3, if we have a number 3, so 3 with the 3, so this bit gonna become 0. Yeah. And for the next one, if it is 2, so the bit with bit 2, 0, 1, 2, it's gonna become 0. Yeah. So if we find the same state like before, so before it is this one, so the index is -1. So this is what I prepared, the index -1. And our current index from here, it is 0, 1, 2, 3. It is 3. So what is the result? It's gonna be 3 minus 1. Yeah. So let's check the result. It's gonna be the maximum of the result with my current index is I. Maybe it is inside the hash table, so I'm gonna use index with the mask. Yeah, if it is inside, or maybe it is not inside. So if it is not inside, I'm gonna enumerate 10 different places because the state, the length of the state with the bit mask, there are only 10 bits. So I'm gonna check each bit. So from 0 to 9, I'm gonna check each of the bits. Yeah. So I will update the result once more. So this is for the odd length of the awesome substring. So if the length is odd, maybe this one from 0, 0, 0 to this one 0, 1, 0, 0. So 3, 2, 3, it is odd. So I'm gonna enumerate each of the bits. I'm gonna flip each of them to compare if I can find one. Yeah. So it's gonna be the maximum of the result with I minus index. So what is inside? So first of all, yeah, I'm gonna update the mask. Yeah, I cannot write it like this, but I just check what the mask will be updated in the temporary state. So the mask will be updated similarly like this. It's gonna be 1 shifted, 1 should be left shifted, Z bit. Yeah. So this means my state is a mask with XOR 1 left shift, 1 left shift Z bit. So it's gonna be like this. Yeah. So this is gonna be inside the hash table. Yeah. So this is just for enumerate the different state. So for example, Z equal to 0, it means bit 0. I'm gonna flip it. So for this number, I'm gonna flip it to 1, and this one I'm gonna flip to 1. Maybe this one I'm gonna flip to 0. Yeah. And then I'm gonna check it inside. If I flip it to 0, it means the index it is index 2 minus index inside. It is this one. Yeah. Minus 2 minus 1, it is 3. So currently it is 3. And while I'm checking this one, maybe it's gonna update it to 4. Yeah. After all that calculation finished, we need to prepare the index array. It is a hash table. Yeah. So the hash table would be with the mask and to the minimum of the index, I. Because this is basically this is the state. Yeah. So the index is the mask. It means the different state, and then we're gonna have the different values. Yeah. So for example, this is I. We're gonna check the minimum with I, and it can become smaller. Yeah. So it's gonna be another index. Let me think. Yeah, basically it is this one. This one must be inside the index array. Yeah, so it's gonna be with index mask. Yeah, so I is my current one. If I didn't have it, maybe it is infinity. This is what I prepared. Yeah, maybe I'm gonna update it to I. So for the first one. For the first one, the index I is 0. So for this one, it is 0. Yeah, and this one is infinity. So the minimum is 0. For this one, I'm gonna store an index as 0, and for this one, I'm gonna store an index as 1, and similarly for this one, I'm gonna store an index as 2. Yeah, I just didn't update this number. Yeah, but basically it's the same idea. So this index is -1. Yeah, basically I need to update the index array. So finally, I just need to return the result. Yeah. So this is why it is so hard for the bit mask problem, because it's really difficult to explain and it's really difficult to calculate. We have to design the bit exactly like this. Yeah, because this is basically n times 10 time complexity. Because for here we only use a loop for z in raise 10, and this is on time, and this is 10. So it is 10 times n time complexity. Yeah, I'm not sure if it is right, but let's just run it to check. As you can see, it works. And for each step, it is specifically designed. It is not we can write the code immediately. We can write everything about them. I mean, for each of the line, it's really difficult to design, and for the result, it is okay. But for the mask, we have to have a special design and update of the state, update of the mask. So the mask is the state, and how to store the state into the index array, yeah, and how to check the minimum, because we are calculating the longest awesome substring. So we are checking the minimum of the index. If we are checking the shortest awesome substring, maybe we're gonna use the maximum of I with the index mask. Yeah. So I think that's for it. Let me submit it to make sure it works. Yeah, as you can see, it works and it's pretty fast. Thank you for watching. See you next time.